Hi, my name is Allison Shields.
I'm Tyler Woods.
And I'm Ashley Odiaga.
Thank you for watching our educational video on coral reef bleaching and degradation.
In the video, I focus on the scientific basis behind coral reef in degradation and bleaching. Many are unaware of the drivers of reef loss, one of the main ones being climate change. I discuss the main causes and effects of bleaching, as well as possible recovery.
I decided to focus on the socioeconomic causes and consequences of coral reef degradation. The causes include overfishing and land-based pollution, while the consequences include deterioration of the fishery and tourism industries. Examining social and economic issues surrounding local inhabitants around coral reefs can help us draw conclusions about the best way to manage coral reef bleaching.
My focus was on the policy and governance of coral reefs. Coral reefs are in dire need of effective governance, yet the science and planning of coral reefs protected areas largely stem from wealthy developed nations with very different social, economic, and cultural characteristics. I will discuss several different management strategies used to govern marine protected areas.
Coral mortalities have been reported since the 1870s, and there's been a large increase in reports since the 1970s. Eutrophication, increased sediment flow, overexploitation of marine species, mining and physical destruction by reef users are the main causes of reef destruction. While these are all very serious and alter the structure of the coral reef ecosystem, one of the biggest threats to coral reefs is coral bleaching, which is the process by which corals take on a pale white color. One of the main features of coral reef ecosystems is the endosymbiosis between corals and zooxanthellae, which are dinoflagellate microalgae. The zooxanthellae photosynthesize while inside their host, providing energy and nutrients to the coral and to the organisms that feed on it. Corals are essential to the coral reef ecosystems, as they provide habitat, structure, and growth for the community. Sudden changes in salinity, light, temperature, sedimentation, and aerial exposure can cause corals to rapidly pale. Chemical factors such as copper ions, herbicides, and pesticides, and biological factors like bacteria can cause loss of algal pigment from symbiotic invertebrates. The process of corals rapidly losing their color has been known as bleaching. In most cases, the rapid bleaching of corals, especially during mass bleaching events, is found to be due to the loss of zooxanthellae and/or the loss of the pigments of zooxanthellae. There are several conditions that are known to cause coral bleaching and mortality. One is a sudden drop of sea level, which results in increased aerial exposure of the reef system. High rainfall can reduce the salinity of the water, which can cause the corals to die. Large-scale sea warming has a major impact on the coral reef ecosystem. Many corals live near the upper limit of their temperature range. Small increases over a period of weeks or large increases over a period of days can cause coral dysfunction and death. Data show that the coral bleaching occurred during times of low wind velocity, clear skies, calm seas, and low turbidity. This is the ideal condition for increased UV penetration and heating. What does bleaching mean for the ecosystem? Immediate effects on coral hosts include a decline in zooxanthellae density, loss of chlorophyll pigment, increase in respiration rate, and decline in coral proteins, lipids, and carbohydrates. Long-term effects include an increasing predator concentration with a decreasing prey concentration, a shift in the live cover dominance to algal turf, macroalgae, and other non-reef building species, an increase in sea urchin abundance on dead reef frameworks, leading to severe bioerosion. Furthermore, bleaching leads to increased rates of coral mortality, decreased coral reproduction, and reduced coral productivity and growth. Will it be possible for coral reefs to recover? Past events indicate that the rate of recovery is dependent on the severity and scale of the disturbance, although geographic location is also a factor. Reefs may recover from minor events in a matter of weeks, though severe disturbances can result in large-scale bleaching and mortality. Recovery may occur via asexual fragmentation, but slowly if sexual reproduction is used. Two of the ways that recovery can happen are acclimation and adaptation. Acclimation is the modification of processes to perform better under the new conditions, in this case under a higher temperature. Adaptation is the selection of individuals that cope better with the new condition. In terms of adapting, paleontological evidence suggests that many coral species are unable to have rapid evolution. The species for which rapid evolution is possible have high genetic variation and relatively short lifespans. How does climate change impact coral bleaching? With global warming, we can increase in the frequency, severity, and scale of coral bleaching. Most evidence suggests that increased temperatures are one of the main causes of the phenomenon. They cause zooxanthellae to leave their coral hosts, altering community structure and function. Climate change is probably one of the greatest threats to coral reefs today.
In coral reef research, socioeconomic consequences of degradation are often reported, especially in tourism and fishing industries. What's less noted, though, are causes of coral reef degradation that pertain to local peoples and their economies. Pristine coral reefs, often called the rainforests of the sea because of their high biodiversity, are wiped out or at risk of degradation mostly because of rising ocean temperatures and acidity. However, at the root of these causes are overfishing, land-based pollution, and global climate change. Overfishing obviously has to do with the economies of societies near coral reefs. Negative correlations were found between the number of people and number of fish in a reef ecosystem, especially for apex predators, which have no predators themselves. This means that a high number of people corresponded with a low number of fish. For fish species, both richness and evenness decline with high human impact on reefs. This means the number of fish species decreased, and there were much fewer of some species than others. Coral diversity may be even more sensitive than fish diversity and may not recover as quickly following protection. There are many local economic impacts of humans on coral reefs. In the tourism industry, snorkelers may touch coral polyps, which are very delicate and die easily. Boats transporting tourists drag anchors, which destroys reefs. People, what are you doing? Because of overfishing, some organisms are dominating reefs that were once kept in check by fish population. For example, overfishing of herbivorous fish that eat algae lead to high levels of algal growth that smother coral reefs. Local pollution, which is a social impact, includes stormwater runoff that carries fertilizers, sewage, and nutrients into the ocean. The increase in nutrient concentration reduces the amount of sunlight reaching corals. Numerous articles cite overfishing and pollution from agriculture and land development as major drivers of coral reef degradation. The social and economic consequences of coral reef degradation are more prevalent in research than the causes. The two major industries affected by reef degradation are tourism and fisheries. Two areas where these consequences are very apparent are the Indian Ocean and the Philippines. Although many tourists surveyed near the Indian Ocean did not know about coral bleaching, 80% said that they would be less likely to visit a bleached area. From an optimistic scenario in which reef protection is realized to a pessimistic scenario in which reef structure collapses, loss of revenue from tourism ranges from $608 million to more than $8 billion. In the Maldives, for example, 10% tourism growth was expected, but only 8% growth was realized. 47% of tourists cited dead corals as the most disappointing part of their visit. Many different types of tourists make up the tourist population in the Philippines, including divers, honeymooners, and general vacationers. Diver tourists made up 50% of the tourists in the 1980s, but only 10% in 1998. The number of budget tourists has stayed about the same, but the number that dive has decreased, and diving losses in the local economy are around $20,000. If tourism losses are permanent, monetary losses are $15 million to $27 million. Welfare losses are around $14.6 million. Welfare loss is a tourist's willingness to pay more to go to a less degraded coral reef. Tourism losses include impacts on tourist destination choice, impacts on choice of activities, and reductions in tourist satisfaction of the diving experience. Impact on fisheries is more long-term because fish biomass in coral reefs will take longer to recover than the tourism industry. As catch rates decrease in the Indian Ocean, catch composition has moved largely to herbivorous species, which are worth less money. As a result, the economic positions of fisheries may deteriorate. Right now, the decrease in fish abundancy is shown in a positive correlation between fishery management and fish abundancy. This means that less organized fisheries are exploiting reefs, which causes lower abundance of fish. However, the impact of reef degradation may be more apparent in the future. Declining catches may be a result of overall environmental degradation. In the Philippines, fishing trends are so variable that it is difficult to tell whether bleaching directly impacts the fishing industry. Overfishing plays a big role, as does seasonality, so we can't generalize about the impacts of reef degradation on fisheries. In addition to providing employment for millions of fishers, fisheries provide sources of protein in poor societies. For example, 25% of fish catch in developing nations is provided from fisheries associated with coral reefs. High productivity in otherwise unproductive waters makes coral reefs critical to the survival of marine ecosystems and to the survival of local people.